Previously, we talked about slope and said that the idea of slope in mathematics is exactly what the idea of slope is in ordinary life. That is, it is the vertical distance that you go divided by the horizontal distance. If you go a small distance horizontally but have to go a large amount vertically, you're in a steep slope. That is a slope which has a large numeric value. If you go a moderate amount, it has an intermediate value, okay, as in here. And if you don't go up at all when you go horizontally, the slope is 0. I don't illustrate it here, but if we were going downhill, the slope would be negative because for every meter you go forward, you'd be going down, which would make it a negative value. Now, what I'm going to look at here, I'll expand this thing a little bit so that we can see what's going on in a little more detail. Here, this vehicle has a velocity of 0, and in fact has had a velocity of 0 for some time, it appears. So, if I look at the different times, the distance is still 0. And if I make a chart of it, with time on the horizontal axis and distance on the vertical axis, no matter what the time is, the distance doesn't change. It's still 0. For this, we've got toy model racing cars, okay? These things are pretty slow. So the velocity is, say, 5 meters per second, but it's greater than 0. And so as time increases from 0 to 10 seconds, the distance increases, starting at 0, because that's when you started out, and it goes up to 50 meters. And that you can see in this slope. As we go along in time, the distance traveled goes up, okay? So after 10 seconds, we've gone 50 meters. Now notice, the definition of slope is the vertical distance divided by the horizontal distance. So if I take the vertical distance of 50 meters and divide it by the horizontal value of 10 seconds, what I'm going to get is a slope of 10 meters per second, okay? Because it's 10 meters divided by, it's 50 meters divided by 10 seconds. Well, meters per second is velocity, and that's what's going on here. The velocity is 5 meters per second, which is 50 meters divided by 10 seconds. So the slope for this chart is actually the velocity. In this case, we have a much faster vehicle, which is going 20 meters per second, so it goes much further. In 10 seconds, it's gone 200 meters. But again, if we take 200 meters divided by 10 seconds, we get 20 meters per second, which is the velocity. This is one of the reasons why slope is so important in mathematics, because it allows you to look at a curve and from that derive how fast the curve is changing and actually put a number on it. For example, if I go back over to these toy cars and I change the velocity from 5 meters per second, okay, I'm going to change it to 10 meters per second. Now watch what happens to the slope down here. See, it goes up. And the reason it goes up is exactly what you would think. As time goes on, okay, as we go along the time axis, we're going a further distance because the velocity is higher. And it's not all that surprising that the faster you go, the more ground you cover in a given period of time. So again, slope here, the slope of this line is telling you something about this data. And what it's telling you is that when you're plotting distance and time, the slope is velocity. And the reason for it is because the vertical distance is in meters, the horizontal distance is in seconds, okay? And it's meters divided by seconds, which is to say meters per second, which is velocity.